Welcome back to the deep dive. We are shifting gears a bit today.
Hmm.
Usually when we're wading through these technical snacks, we're talking about consumption. How to query data, how to filter it, how to read it.
Right. We act like the data is just sort of there, like it's naturally occurring.
Exactly, like ore in the ground waiting for us to mine it. But today we're putting on the hard hats. We're talking about the C in CRD.
The create. It's about time we got there.
It is. We are looking at the SQL insert statement. We've got a stack of documentation here, some really specific exercises involving the Chinook database. And we're going to break down how a record actually begins its life.
I like that.
We're moving from being the people browsing the library to the people actually writing the books.
That's a great way to frame it. It really is a shift in mindset. When you're running a select statement, you're an observer. A sophisticated observer, maybe, but you're passive.
Right.
When you run an insert statement, you are an active participant. You are establishing the truth of the database. You're altering the reality of that system.
And that feels like higher stakes, doesn't it?
Oh, absolutely.
If I mess up a select query, the worst that happens is I get 0 results or, a messy table. I just fix the syntax and run it again.
Sure.
But if I mess up an insert, well, now I've put garbage into the system.
Precisely. You've corrupted the memory. And cleaning that up is a lot harder than just fixing a typo in a query.
Yeah.
That's why the source material today is so specific about syntax and structure. It defines insert simply enough, the command used to add new records or rows,
Yeah.
but the actual execution is it's a strict contract.
Okay, so let's look at that contract. The syntax in the documentation is insert into, followed by the table name, then a list of columns, and then the values keyword. It feels incredibly rigid.
It has to be. Think of it as a handshake protocol. The database engine is waiting for you to tell it two things. Where are we putting this, and what exactly are we putting there?
The visualization that always helps me is like filling out a government form. You have the labels on the left, name, rank, serial number, and the empty boxes on the right.
That's the perfect analogy. The column list in your SQL statement, that's those labels. The values list is what you're writing in the boxes.
Okay.
And the source material emphasizes a critical point here, alignment.
Right. The order matters.
A lot. It's not smart enough to figure out what you meant. It's literal. If you list your columns as name, job title, but in your values you write manager, Steve.
Oh, you end up with a manager named Manager and a title of Steve.
Exactly. Or if the data types don't match, say you try to shove that text string manager into a column that expects like a salary number,
It just fails.
the database is just going to reject the application entirely. It rips up the form and throws it back at you.
So we have this stripped list, but here's something in the source material I found interesting. It brings up the idea of shortcuts. Because let's be honest, if I have a table with 50 columns, writing out an insert statement where I have to map 50 values sounds, well, miserable. Do I always have to fill out every single box on the form?
Thankfully, no. That would make database administration and software development in general unbearable.
Right.
The documentation highlights two specific scenarios where you can omit a column from your insert statement, and the database will just handle it for you.
The first one feels pretty intuitive. Default values.
Right. If you're designing a table for, say, a user account, you might have a column for eyes active. You can set the default to true.
I see.
So if you don't mention that column in your insert statement, the database just assumes you want the default and fills it in.
It's like the form having a pre-checked box.
Exactly. But the second scenario mentioned in the source is the one that really matters for our Chinook database exercises.
And that is?
It's the auto-incrementing primary key.
Yes, the artist did.
In the Chinook database, every artist needs a unique ID number. It's the primary key. It's how the database identifies that record uniquely. But the source material says, and I'm quoting here, because the artisted column is an auto-increment column, you could ignore it in the statement.
So I don't have to check what the last number was? I don't need to worry about that?
And you shouldn't.
Why is that shouldn't so important? Is it just, laziness, or is there a technical reason?
It's about concurrency and safety. Imagine if you and I were both trying to insert a new artist at the exact same millisecond.
Okay.
If we both had to manually look up the last ID, say it was 100, and then pick the next one, we both try to grab 101.
And we'd have a collision.
Right, one of us would fail.
Yeah.
By using auto-increment, we delegate that housekeeping to the database engine.
Ah.
We just say, here is a new artist named the Deep Dive Band, and the database says, okay, get in line, you are number 276. We don't even need to know the number to create the record.
So it effectively decouples the content of the data from the indexing of the data.
Exactly.
I can focus on the artist name and let the system handle the ID number.
Precisely. It allows the system to scale without the user stepping on each other's toes.
Speaking of users, let's talk about where we are physically doing this. The source material points us toward a tool called dbeaver.
Which is a fantastic open source GUI, a graphical user interface.
Right. And we're connecting to chinook.db. For those listening who haven't seen Chinook, it's a sample database. It represents a digital media store, so it's got artists, albums, tracks, invoices.
All that stuff.
It's complex enough to be real, but simple enough to learn on.
It's the classic sandbox.
Now, in the exercise, it guides us through connecting to Chinook in dbeaver and running an SQL script to add a new artist. But I have to play devil's advocate here.
Okay.
dbeaver is a visual tool. I can see the tables. I can right-click. Why am I typing out insert into code? Can't I just click add row?
You can. And for a quick one-off fix, that's perfectly fine. But the expert insight here, what the source is really pushing you toward, is understanding the engine. Because when you click that Add Row button and type AC/DC into the little grid, do you know what dbeaver is doing in the background?
I assume it's writing the code for me.
Exactly. It's generating that exact SQL insert statement and firing it off to the database. The GO is just a translator.
So if I rely only on the GUI, I'm basically relying on a translator to speak the language for me.
And that works until you need to automate something. You can't click a button inside a Python script. You can't click a button from a web server. To actually build software, you need to speak the raw language of the database.
That makes a lot of sense. It's the difference between driving an automatic and knowing how the transmission actually creates torque.
And that leads us perfectly into the problem of scale. Because clicking Add Row works for one artist. But the source material pivots pretty quickly. It asks us to add several playlists and add several albums.
Right. This is the batch processing section.
The basic syntax we started with values, X, Y, that creates one single row. If you just bought a catalog of 5,000 songs and you need to load them, writing 5,000 separate insert statements
Would take forever and be really boring.
It's not just the typing, it's the performance. Every time you send an insert command, the database has to wake up, parse the text, check the rules, open the file, write the data, close the file. Doing that 5,000 times is incredibly inefficient.
So how does the SQL syntax solve this? The source shows a modification here where we use commas.
It's a very elegant solution. Instead of values, record 1, you write values, record 1, record 2, record 3. You just chain them together.
So it's one single command sent over the wire.
One command. The database opens the door once, accepts the entire shipment, and closes the door once.
The efficiency gain must be massive.
It is. In the source exercise where you're adding multiple albums, using a batch insert is the difference between the script running instantly versus, watching a progress bar crawl across the screen.
So the takeaway is, don't loop, batch.
Always batch.
Okay, so we've got the manual SQL, we've got the batching, but now we get to the part of the source material that I think is the most relevant for anyone wanting to be a developer. We leave dbeaver behind.
Right.
We open up Python.
This is the big context switch. We stop being database administrators and we start being engineers.
Because in the real world, you aren't sitting at a console typing insert statements every time a new user signs up for your app.
God, I hope not.
Right. The code does it. The application logic handles the creation, and the source introduces a specific data structure for this, the tuple.
Yes.
Now, for those who aren't Python experts, a tuple is basically a list that you can't change, right? It uses parentheses.
Correct. It's an ordered, immutable collection. And the source material is very specific. The tuple represents one row.
Why that structure specifically? Why not a list or a dictionary?
It goes back to that contract we talked about earlier. The database table is rigid. Column 1 is name, column 2 is ID. A tuple reinforces that rigidity. The order is fixed. You bundle your data into that tuple, say, my playlist 120, and it becomes a sealed package representing that row.
Okay, so I have my package, my tuple. Now I need to hand it to the database. And this is where the source material gets into something that looks, well, it looks weird if you've never seen it. It talks about parameterized queries and using a question mark.
The humble question mark.
Yeah, insert into table values. It looks so abstract. My instinct, if I didn't know better, would be to just use string formatting. Just create a text string in Python, like .squal, insert into table values, plus user input, plus...
Right.
Why does the source tell us not to do that?
That is the single most dangerous habit a new developer can pick up.
Dangerous like the code crashes, or dangerous like I just got hacked?
Both. The source implies the best practice here for stability. but it's really about security. Think about it. If you are just gluing strings together, you are trusting the content of the data to play nice with the structure of your command.
Okay.
What if the song title has an apostrophe in it, like "Don't Stop Believin'"?
Oh, right. The SQL command uses apostrophes to mark the start and end of a text string.
Exactly. So if your data has an apostrophe, the database thinks the text has ended. It sees the rest of the title as some weird broken command.
And it crashes the query.
It crashes. So the
Yay.
code breaks just because the song title was grammatically correct.
Whoa.
Yes. And that's the benign version. The malicious version is something called SQL injection, where someone intentionally inputs code to trick your database.
Yeah.
But let's stick to the source material's context here, which is stability. By using the question mark, you are creating a placeholder,
A parking spot.
a reserved parking spot. You send the SQL structure with the question marks first. The database looks at it and says, okay, I see the structure. I see where the holes are. Then you send the tuple the data separately. The database engine safely slots the data into those holes.
So it never treats the data as part of the code. It treats it strictly as content.
Exactly. It's a clean separation of concerns.
Yeah.
And looking at the Python exercises in the source, this is why they emphasize that syntax so much. It ensures that no matter what weird characters are in your playlist name, the insert just works.
So question marks are our friends. They keep things clean.
They keep things running.
Now, speaking of keeping things clean, we need to talk about the messiest data type of all, time.
Date time, the nemesis.
The source material has a specific section on insert date time. It uses the employees table in Chinook as the example.
Right, because an employee record isn't just a name. It has a birth date and a hire date.
And the exercise notes imply that we can't just free text this. I can't write January 25th, 2026 or next Tuesday.
No. This brings us back to the bureaucrat analogy. The database expects a standard format.
Yeah.
Usually, that's ISO 8601, which is YYYYMMGD. If you try to hand it a date that doesn't look like that, it rejects it.
So in Python, when we're building that tuple for the new employee, let's call him Steve. We have Steve for the name. But for the hire date, we need to transform that into a specific string the database understands.
Yes. You are stamping that record with a precise point in time. The insert statement is where that formatting has to happen. You're bridging the gap between how humans talk about time last week and how computers store time. 2026-01, Jano 00000000.
It really highlights that insert isn't just about dumping data. It's about data modeling. You have to understand the shape of the container before you can pour anything into it.
That's the perfect synthesis. You cannot build without a blueprint. The table definition is the blueprint. The insert statement is you following it.
I want to circle back to something before we close out. We've talked about the mechanics, the syntax, the batching, the Python tuples, but I was looking at the list of exercises in the source. Add artists, add albums, add playlists. They are listed as separate tasks.
Right. Distinct deliverables.
But in a relational database like Chinook, they aren't really separate, are they? This is something I wanted to get your take on.
No, they are deeply interconnected, and this is where we move from just typing code to system design.
So let's say I decide to go rogue. I want to start my day by inserting a new album. I create the tuple, I format the query, but I haven't created the artist yet.
You're going to hit a wall. In the Chinook database, the album table has a column called articity. It's a foreign key.
Which means it has to point to something real.
It has to point to a record that actually exists in the artist table. The database checks.
So it enforces that link.
It enforces what's called referential integrity. It says, you're trying to link this album to artist hashtag 500, but artist hashtag 500 doesn't exist, and it blocks the insert.
So the order of our creation matters just as much as the syntax.
Absolutely. You have to lay the foundation before you can frame the house. You must insert the artist to generate its ID so that you can then use that ID to insert the album.
It's a dependency chain.
It is.
Yeah.
And realizing that is the moment you stop just being a data entry clerk and start thinking like an architect. You have to plan the sequence of creation.
That is a fantastic place to land. We started this deep dive looking at a blank shell. We learned the contract of the syntax, the efficiency of auto-increment and batching, the safety of parameterized queries in Python, and finally, the architectural importance of order.
We moved from how do I type this to how do I build this?
And that's a mission. For everyone listening, next time you sign up for a service or add a song to your playlist or even just save a document, think about that split second where the insert statement runs. Think about the tuple being formed, the constraints being checked, and that new reality being stamped into the digital memory.
It's the spark of life for data.
Thanks for diving in with us.
Always a pleasure.
We'll catch you on the next deep dive. Keep building.